This is the last week of Affirmation 10, which is faith and science, doubt, and the pursuit of truth. Hey.
Where are the pens supposed to get?
You can get your notebooks and papers and pens when you go to your discussion group. So we're gonna look at a couple of concepts tonight that are kind of, well, it's actually kind of one concept presented in two different ways. So
the faith singers looks real be sitting there.
you can just get your papers when we go to our discussion groups.
I guess we'll get them when we go to the groups.
It's not that hard of a one.
All right.
One more absurdity, one more claim that science makes that perhaps tops them all, and yet we have proof. Science now claims that the universe, the mass of the universe, if you could like weigh the whole universe, just put it on a scale, weigh it, all right, that there's actually over three times that mass that's out there that we can't even see, touch, feel, even weigh actually, that it exists, it's present all throughout the universe, and it doesn't act like any form of matter that we know of. It's completely not there, but there. And the only way that we even know it's there is because it has a very weak effect that can be measured, that acts a bit like mass, even though it's not made of atoms as we know that atoms are mass. Scientists call this dark matter. Now, dark matter is neither dark nor matter. They call it dark because it doesn't emit light, and nor does it absorb light. It just, so when it stands against the darkness of the universe, you see right through it, everything looks dark. And they call it matter because, well, what else can you call something that it exerts? What it does is it exerts gravity like mass, even though there's no mass there. You can actually measure its gravitational effects. Okay, is that starting to cause the synapse to explode yet? Okay, so it would be like if I were to claim that I'm not up here alone, that there's actually three invisible men behind me. And there are three invisible people behind you too, and only, unlike the invisible man, you can't feel or touch this person. It doesn't speak or anything, but it's there. And we know that that invisible man is there because of the gravitational effects of that invisible man. And of course, any mass in the universe has a gravitational pull. You have a gravitational pull, but it's so small, gravity is so weak that you can't measure that. Nobody can measure that. It takes giant mass before you can measure even the slight amount of gravity. So, for instance, the Earth, the whole mass of the Earth, has a very weak gravity to it. It's enough to keep us on the ground, but we can actually overcome that force simply by jumping, right? If we just had could sustain the energy of that jump, we could actually go into orbit if we wanted to, right? So gravity is very weak. It's one of the weakest forces in the universe. And yet when you have huge mass, it's there. Okay, so how do they know the dark matter is there? Well, you see, Einstein once said that gravity has the capability of bending light. If you have a giant mass in the universe and light's going right at it, gravity bends the light around it. That sounds insane, but that's actually certifiably true. And what they found is that they can look at, like, say, a star. Like, say that light is a star. And if we're just looking directly at it, what scientists can notice is that the light bends between the star and us, even though there's nothing in between that could possibly have the kind of mass that would bend that light. So they speculate that's dark matter. In fact, using the Hubble telescope, they've actually created a whole map of the dark matter in the universe. Bear in mind that none of that could be seen, touched, or felt, but there's the dark matter. Now, another way they know about there's dark matter is through someone or something called Mira. Mira is not a person. but a supercomputer that's not too far away from us. It's over near Chicago. And Mira is really about 2,000 huge computers, all daisy-chained together, that are capable of performing 10 quadrillion calculations per second. Now, even running that fast, it's only the third most powerful computer in the world. But it's powerful enough to actually crunch the giant numbers to recreate the universe as we know it inside the computer. And what they did a couple of years ago was they fed all of the known knowledge about the universe, about the physics and all that, into this computer in order to recreate the Big Bang and see how the universe dispersed itself using the known universe. So they fed it all into the computer, and they gave it took several weeks to crunch all those numbers, even at that rate of speed. And what they found was the universe, using the known laws of physics, never created itself after the Big Bang. It didn't have enough gravity to actually pull together stars and galaxies. That it all just kind of went, and just was all uniformly distributed throughout the universe. So what they had to do was they had to crank the dial up on gravity. Let it go again. Now it's still no universe. So they cranked it up again. No universe. They kept cranking up this dial, letting it go for several weeks to crunch those numbers until they reached the figure of 84% more gravity in the universe than we know about. And once they hit 84%, the picture that was created of the universe in that supercomputer looked exactly like the picture of the known universe. Talking about freaking your freak. Yeah. And only very recently, then, once they were assured that the number was correct, they let Mira go wild and actually recreate the extent of the known universe within itself, so we could see it. And the picture recreated by Mira is this one. If you could look at the entire observable universe at a glance, this is what it would look like. What you are seeing is so vast that even a 20th of that screen would represent about 400 million light years. It's so vast that every single dot of light on there doesn't represent a star, it doesn't represent a galaxy, it represents a whole cluster of galaxies. Every single dot. If you zoom in a little bit, and I mean only a little bit, that's what it looks like. That's what our universe looks like. Every single dot of light, a cluster of galaxies. Does that look familiar? Like something you saw before? Oh. The brain cell. On the left, a scale of 400 million light years in a little bit. On the right, the scale of 1,000th of a millimeter. When I behold that resemblance, I don't start, and that resemblance was caused by all this dark matter, this invisible matter that nobody can touch, taste, feel, or smell, and yet we only know it because it exerts an invisible force. I do not start thinking, oh, dark matter must be God. But I do start thinking, that's really absurd. Who would have thunk it? That the whole universe is wired like our brain. And that our brains are wired like the universe. That.
What did you guys believe, Eric? What do you guys think? Do you believe what Eric was saying there? Hello?
Yeah.
Anyone? Have you heard that before? Dark matter? Alright, well here's a scientist to talk about it.
The question isn't about whether dark matter exists or not. What's going on is when we measure gravity in the universe, the collective gravity of the stars, the planets, the moons, the gas clouds, the black holes, the whole galaxies, when we do this, 85% has no known origin. So it's not a matter of whether dark matter exists or not. It's a measurement. Period. Now, dark matter is not even what we should be calling it, because that implies that it's matter. It implies we know something about it that we actually don't. So a more precise labeling for it would be dark gravity. Now, if I called it dark gravity, are you going to say, does dark gravity really exist? I say, yeah, because 85% of the gravity has no known origin. There it is. Let's figure out what's causing it. The fact that the word matter got into that word is forcing people to say, well, I have another idea. I bet it's not matter. It could be something else. We're overreacting to a label that overstates our actual insights or knowledge into what it is we're describing. Then I just joke we should just call it Fred. Fred or Wilma. Something where there is no reference to what we think it is, because in fact we have no idea. So here's how you actually measure the stuff. In a galaxy, which is the smallest aggregation of matter where dark matter manifests. So you look how fast it's rotating, and we know from laws of gravity, first laid down by Johannes Kepler and then enhanced and given further detail and deeper understanding by Isaac Newton. You write down these equations and say, oh, look how fast it's rotating. You invoke that rotation rate in the equation, and out the other side says how much gravity, how much mass should be there attracting you. And the more mass that's there, the faster we expect you to be orbiting. That kind of makes sense. So when you do this calculation on a galactic scale, we get vastly more mass attracting you than we actually can detect. I'm adding up stars, gas clouds, moons, planets, black holes. Add it all up. It's a fraction of what we know is attracting you in this orbit. And we cannot detect the rest. And so we hand it this title, dark matter. Understandably, I suppose, but it implies that we know that it's matter. But we don't. We know we can't detect it in any known way. And we know it has gravity. So it really should be called dark gravity. I think the over-under on what dark matter might be today, I think we're all kind of leaning towards a family of particles, subatomic particles, that have hardly any ability to interact with the particles we have come to know and love, quote, ordinary matter. And that would make it matter, dark matter, as we've all been describing it. And it's not a weird thing that you could have a particle that doesn't interact with our particles. Within our own family of particles, there are examples where the interaction is very weak or non-existent. You might have heard of neutrinos. This is a ghost-like particle that permeates the universe and hardly interacts with familiar matter at all. Yet it is part of our family of particles that we know exist and that we can detect and interact with. So if we can have an elusive particle that's part of our own familiar family of particles, it's not much of a stretch to think of a whole other category of particles where none of them give a rat's ass about the rest of us, and they just pass right through us as though we're not even there. Now here's what's interesting about dark matter. We know it doesn't interact with us, except gravitationally. By the way, what do I mean by interact? Does it bind and make atoms and molecules and solid objects? No, it does not interact with us in any important known way. But it also doesn't interact with itself. That's what's interesting. So if it interacted with itself, you can imagine finding dark matter planets, dark matter galaxies. Because to interact with yourself is what allows you to accumulate and have a concentration of matter in one place versus another. These are the atomic bonds and the molecular bonds that create solid objects. And if particles do not interact with one another, they just pass through, you just have this zone of mass, not really doing anything interesting. So dark matter not only doesn't interact with us, it doesn't interact with itself. And that's why when we find dark matter across the universe, it's very diffusely spread out. It's like over here. It's not in this one spot and look at this concentration. No, that's not how that works. An example of this, what is a rock? It's a collection of atoms and molecules that are stuck together by electromagnetic forces. We don't think of them that way. We just think of them as rocks. But they are held together by forces on the atomic and molecular scale. And they bind together, and then we get what we call the solid object called a rock. If those forces did not work on you as a particle, you have no occasion to bind with any other particle. You have no occasion, you have no ambitions of ever becoming a solid object. It's a different kind of world that would be. We would not expect that world to have life as we know it, because life requires an assembly of molecules to turn it into some separate entity distinct from everything else that then has fascinating chemical properties that we call life.
Oh, look, it's So, did you guys understand all that? No? Are you not a scientist?
No, I knew everything.
Who are the, Jason, who are the scientists here? We probably have some.
Somewhat. You're a scientist. What's Einstein's name? He's a scientist.
Just wait. Wait till we're done. You said you're a scientist? A little bit? What was the point of the dark matter thing?
Dark matter allowed this universe to form, because if we didn't have dark matter, we wouldn't have enough gravity to form, and we just kind of no life would exist.
Yeah, that's good. That's interesting too, isn't it? When did you learn about that?
From the video.
Just today?
She might be our scientist. My goodness. That was
Yeah.
awesome.
I'm in physical science, so we do chemistry and physics. And in chemistry, we were talking about some of the atomic particles. And it came up in one of our lessons, but we didn't talk much about it. And they mentioned that, how it's similar to the brain.
Mm. Yeah. Eva, did you have your hand up? Any other scientists? Yeah? What did you think?
Basically, like it's something that we can't feel or touch, and it can just pass through us, and it's just in the universe, and we can't do anything with it.
Yeah.
It makes me think, if it's wired like a brain,
Hey.
if it's wired like a brain, does it mean that we could really be inside of a brain right now?
Oh, brain in a brain. Where does it end? I thought one of the interesting things was that, didn't he say like 85% of everything out there is dark matter. I mean, dark gravity. It's just a word. Fred.
Right, Fred. I love Fred. I like thinking the other way. I like how we as humans say that we compare it to our brain, but our brain was made after that. So our brain is like dark matter.
Which makes you think like that we're really connected to the universe and connected to probably, I mean, they'll discover something about matter that's similar to at some point, that we're kind of all connected. We're made of the same stuff, right, Jared?
Yeah, he did that.
And how many of you think that the Earth and all of us on it, I think you're good there. Good to the last drop. That the Earth is in the center of the universe. How many people think the Earth is in the center of the universe? What?
That's what cavemen used to think.
Cavemen?
Yeah.
I heard a talk recently. Talk about that for a second. All right, we're almost done here, so let's hold it together. So I heard a talk recently that really in terms of our species, we are on like the corner of the universe. We're not even on the corner, we're like in the margin. But the way we grow up is that we think that we're the center of the universe. And I think what this discussion of dark matter proves is that there's so much that just is out there that we have no idea about. And so really our lives are on this like margin of the universe, and that should put us in a more humble place, I think. Hey guys, I think it should put us in a more humble place, you know, that there's just this immensity out there. Who had it? Paul, were you going to say something real?
I think there's a black hole in the center of our universe. Yeah.
Okay.
So we read that if we were in it.
Just while we're on the topic of science and faith, this is just a fun fact that I know, and when you say it, I just didn't know. I just didn't say it. Did you know that when you die, 7 ounces of your body disappears? It does. Like, it's only scientifically proven this. It's really freaky. So with a whole, there's like a whole book written about it.
Our life force.
Maybe it's air.
It's really weird.
Okay, in Angie's group, you're going to come and get your notebook and then go to your groups. Angie's going to be in Memorial Hall. Hang on. Oh, you're in there. Ellie, Lance, Mitchell, Abby, Virginia, Audrey, Ava, Lures, Gretchen, Eva, Madeline, Caduce, Carly.
Like someone, I know, you guys go to the work that